Today's video I'm gonna show you what project I'm working on here, and trying to um, parallel lithium-ion batteries in conjunction to other batteries with a higher capacity, and this was a kind of lower capacity. So if you look at here, you see 272 amp hours, and the other side here is a 450 amp hours. It's a Volkswagen e-Golf batteries, and you can see all kind of connections I'm doing here to to parallel them, how they can come to two Victron smart shunts. Each battery bank has its own Victron smart shunts and disconnect on both Volkswagen e-Golf batteries here. You have 12 modules there, 12 of them, 6 in parallel, 6 in parallel, and series. Gives us a 24 volts since we're using an Outback. So we're charging right now. We're using an Outback, and so we decided to go about this route and get bus bars here, can handle up to about 450 amps. And this connector 48 volts is a blue seal, and this other one, it takes about 200 and it's a 50 volt max. We can take up to about 400 and something, 250 to 400 amps. So these are all the wires, kind of spaghetti right here, but this one comes back here. This one, I can give you the specs on this Ford Focus batteries, and you guys have seen this video for a long time. And this one can work about 12 volts, 24, 46, 36, 48 volts. And these are the batteries that I've been working on, I've been storing, I've been saving, I've been utilizing them. I missed them a couple times when they're out there, and I wasn't prepared, and I don't have solar money to spend. I don't have money to spend on solar that time. So I'm giving you the specifications on these batteries right here. These are Ford Focus batteries. I've had them for a long time now. So what happened now, you can see on this side here is a 4 single modules. So each module is made of 8 volt modules, is a 2S5P. So it's a 8 volt. So how this entire system thing was designed, you have to have 3 of these. Each one is a 16.7 volt. 1, 2, 3. Then incorporated one of these single one here. So when I bought them, it just came with 2, because the 2 sets of batteries here. So if you count 1, 2, 3 is one 48 volt battery. 1, 2, 3 is another 48 volt. So you have to have one of these 8 volts. The 3 of them comes to about 50 something point something volts. When you add this, it gives you the 48 volts configuration that comes to the 58.8 volts. So what I've done, I decided to buy, there's an opportunity for me, and I decided to grab it and buy these batteries years ago. And I decided to use it because they're flexible. You can enable to do whatever you want to do on any project. That's why I like them. So if you look at it, it's a 3 point something kilowatts, 3.5 kilowatts, something like that, battery. I suppose that's what it is. But if you divide this number, is equal volt times, the volt times the amps of these at 24 volts, you see how many kilowatts of power right here. I'll tell you in a bit. So what happened here, at a 12 volt, this module, each module is you can produce about, when we do, according to the test, it's going to give you at the 30 amps the continuous draw, the continuous current is 150 amps, and at the peak you can take up to about 240 amps at a peak for few seconds, maybe 2 milliseconds or maybe 10 milliseconds, something like that. But you can able to pull continuously 150 amps continuously. According to my test, it's 68 amp hours each module, 68. So I calculated all this one. It gives us to all this if I put them together, because this is considered as one battery. Two of them is one battery, which is 16.7 something, and this as well. So 1, 2, 3, 4, 5, 6, 7, and 8. So if you calculate, multiply 68 times 8 of these at a 12 volt, and you're gonna end up with a 544 amp hours. If you decide this 544 amp hours at a 24 volts, you're gonna divide 544 amp hours divided by 2, because that's a 8S. So 12 volts is a 4S configuration. So that gives you 544 at the 12 volt. At the 24, you divide that by 8. So then it's gonna give you that's gonna give you 272 amp hours, which are stamped right here. And at a 48 volts, okay, so we're losing amperage, but we're gaining the voltage. So 48 volts, we're gonna see that the entire 8 modules here gonna end up being at 136 amp hour storage. So it depends what you want, or it depends on the inverter you have or the system you want to build. At a 12 volts is a bang for the buck. You get a 544. At a 24 volts, you dropped, because the voltage goes up to 24 volt now, and you're losing the amps because you get a series these batteries, 2 batteries in series. It's not parallel anymore. 2 batteries in series, two batteries in series, 2 batteries in series, and parallel them all. So this is what I did here. 2 batteries. This is 4 batteries there, 4 modules. They become 2. There is 2 here, 2 here, and 2 here for 24 volts. So for 48 volts, I have to come from here, and 1 here, 2, 3, and I have to take one of this little guy, the orange ones over there. This one. So after 1, 2, 3, I have to put the little one in between here to give me the 48 volts, because the 8 volt module. So the 16 volt module, like one of these guys, is a 4S5P, and the little guy here is a 2S5P. So 2 batteries in series in there, and parallel them, which is a parallel into 5 parallel. Okay, 2 in series and 5 parallel. So here now it's gonna be a 4 in series inside one module, one brick here, but they're 5 in parallel. That's what it is. So right now what I've done, I get all these things, they have their own bus bars, all of them negatives. So I use a number, I think it's a number 6. I use a number 6 welding cable. I think you can see it right there. A US, I think it takes up to 600 volts, if you can look at it closely. This is a Royal Excellent cable. These are expensive cables and made in the USA. So it's a South wire cable, and yep, it says number 6 right here, and set them up for this configuration. So each 2 batteries in series, I'm gonna be having come to the bus bar, come to back. So that's why I have 4 positives in here, 4 negatives over there, and bring them to the buses and put a disconnect right here. It has a fuse right here for the Victron smart shunt, and that one runs all the way to the back, this one here, so I can measure the capacity that I set the parameters. The voltage are all the same in comparison to the Volkswagen e-Golf batteries. They're all embedded here, you can see them, so they're all there and all the way here. So the same thing I did. I don't want too much serious things. I just put 4L 1 2 3 4 5 6. See the jumper right here? It gives it the 12 to 24 volts configuration, all in parallel. The blacks there all the way. There's another on the other side, far corner, and that will be the switch right here. There's our own bus bars right here, and it has its own shunt right here, a smart shunt. That's the one for it. And then we have a main lead coming out from here. It goes to this guy right here and comes to the inverter. Okay, it comes to the inverter. So then I have a 3 hot cable, 3/0 cable that runs here, that goes to 3600 watt inverter, 24 volts. So to drag all these things right here and get them to the inverter when it's needed. And this is how we're setting up this configuration to see how things gonna work in conjunction to the same voltage with the Volkswagen e-Golf. And these are lithium-ion batteries, not lithium-ion phosphate. So we're talking about here the Volkswagen e-Golf at 24 volt. They're set up right now. It runs at 450 amp hours, and this is 272 amp hours, 24 volts. But if they would have been at 12 volts, they would run up to about 544, while the Volkswagen e-Golf gonna be 900 amp hours. So it's gonna be a drag. So this comes to the question why some people will say, oh, like a BMS, you can have different batteries you can set up, because the BMS can able to understand how the charging is. But I'm trying to save the daylight or save the time for certain people that don't want to deal with the BMS, or they don't know what they're doing with the BMS and all that craziness. So this is what I've implemented for folks like you to able to understand that you can able to parallel your batteries with a different amp hours, which is not going to be any problem or any fight, and everything is just going to be running great. So that's what I did. But I have to use 2 shunts and Victron smart shunts, so I have to use 2 of them, so I can program the capacity of 272 amp hours on one, and it's going to be the other one is going to be 950 amp hours. So that gives us a total of 722 amp hours on 24 volts. If you calculate all these 722, if you multiply these guys here, which is a 1063 watt hours per module, and this one here is going to be like a 3.8, I think 3 point something. I'll add it in the description below. The Ford Focus batteries, it has a high wattage, but the amperage is low. But this is what it is. They work properly, and I'm charging them right now. That's what you're seeing, and everything is you can hear the fan on the background, and they are absolutely charged. Now we're sitting at 32.8. I have higher DC inputs on my inverters, so it might not work for you to charge your batteries that way, but for me it works because my inverter has a higher input, and because of that I can able to do a lot of things other guys cannot able to do because my inverter can tolerate that. So if I have to do a 48 volt and I have to put 4 of these batteries, the Volkswagen e-Golf, in series to be 4 of them, then you're going to be for 48 volt. 12 volt is the same. I can put 2, 36, I can 3. So it's just a 12 volt bricks. So that's what it is. So I don't want you guys to be confused, and I just want to show how I've done it here. So then I can able to utilize these batteries that have been sitting. They're sitting for projects, and the project has to be executed. Well, because of that, I still have to energize them once in a while. So this is what it is. 722 amp hours altogether, and it's a lot of power here. I'll give you the calculations and put it on the description below, the total kilowatt hours we're dealing with here. Thanks for watching. Love you guys all. Stay tuned. Live from the command center of the JW Solar USA. Please don't forget to like, share, and subscribe. Love you guys all. And stay safe. Happy Sunday. Oh, so if you can watch the app closely, you can see shunt. I put in the Volkswagen e-Golf, and you see 450 right there. Then I have Ford Focus 272. There's a charge controller over there. Carried Canadian Solar, and I have other ones here, and 585 watts. And you can see they're all synchronized, and I make sure that they sync together. And right now you see a 32.96. Look at the other shunt right here, 32.95. So it fluctuates 95 and 96. Finally, the fan just keep quiet, and you see everything is ready to go. So what we're gonna do, we're gonna zero out whatever resets the meter, how many watt hours or watts were the energy we took from the thing, and we can go back and see how much total kilowatt hours we can able to do a load test here, how much power we can take out. Okay, this is 100%, and you see, and that we come to this, you see we can able to say they already sync, whatever, do that, or we can go back to this, what I've done here. Here, you're supposed to go to the history. I forgot to do that. Okay, we go to the history right here and see how much power we've drawn from this, and you're gonna show us how much power we charged. Okay, and we go reset this, and it's gonna go 0 0, and we go back to this. We're gonna target the Ford Focus shunt, and we're gonna go back and zero out on the history, and go back here. You see how much, 1.2, and go right there, zero it out, and 0. And we have to go back to the battery thing here and make sure we are synchronized. Say this is our full charge thing, so we already synchronized the battery. So right now we go back here. What I'm gonna do, I'm gonna parallel the batteries now. So we have the Ford Focus charged earlier, and this one was the one we were charging. It's on. So I can go back here and flip the switch, and the batteries are linked. So they're linked together. So let's look at the inrush to see if there is any variation. This is the shunt. It says 0.40 and 0.12. Now we took the auxiliary power out, which is the AC input, and see what is there. So the battery is already connected now. Earlier you see the Volkswagen e-Golf wasn't having anything here. It's 0. So the batteries are all balanced, charged at the same parameters, 32.9 and 32.9095. This is point is fluctuating 95, and this is how everything works. So I hope you understand this, you like it, like and subscribe, and thanks for watching. Stay tuned. Make sure you share this video, please.